So really, the first law of thermodynamics is just another way to describe the conservation of energy, which keeps coming up in our lessons because it's such a key principle of physics. There's always some kind of heat loss, like through friction. Even that tiny amount means that the motion can't continue forever. It will eventually run out of the energy it needs to drive the work it's doing. That's part of why the drinking bird isn't a perpetual motion machine. It relies on the energy it gets from the cup of water to power its movement. The bird is filled with a fluid that has a low boiling point, so it can easily change from a gas to a liquid and back, with just a slight change in temperature. When the bird's head dips into the cup, it gets wet. It keeps bobbing back and forth for a while, and as the water evaporates, it cools the vapor in the bird's head, which condenses into liquid, creating a partial vacuum in the head. That makes liquid travel up the tube. The head gets heavier and dips back into the water. But the tipping makes a bubble rise through the liquid into the bird's head, sending more liquid into the bottom and setting the little bird swinging and starting the cycle all over again. Now, there are 4 basic types of processes where the thermodynamic properties of a system, generally an ideal gas in some kind of container, can change according to the first law. In each case, one property is held constant, volume, pressure, temperature or heat, while the other properties change. Variations on all these properties are used in all kinds of machines, especially engines. First, there are isovolumetric processes where the volume is held constant, usually because the gas is in a rigid container, while heat is added or removed. As you add heat, the pressure of the gas will increase and so will its temperature. As you remove heat, the pressure and temperature would decrease. But isobaric processes, where the pressure is held constant while heat is added or removed, are a little more interesting. Here, the volume of the container is allowed to change, usually because the gas can move a piston. As you add heat, the volume and temperature of the system increase, and as you remove heat, the volume and temperature decrease, which means that an isobaric process can do work. Here is the pressure of the gas times the area of the piston. So work is equal to the gas's pressure times the piston's area times the distance it moves. And one more step, the area of the piston times the distance it moves will be equal to the change in the volume of the container. So the work done during an isobaric process is equal to the pressure of the gas times the change in the volume. If heat is added,